Okay, so the first question is about what is meant by the term current, and current is the flow of charge. So remember that current, which is I, is equal to charge divided by time. So it's the amount of charge that flows in a given time. The three wires of the 3-coil cable are different colours, so you need to make sure you're aware of what these colours are. Okay, so this neutral wire is blue and the live wire is brown. So the second letter is an R, so that goes on the right hand side, and the second letter is a L, which goes on the left hand side. So you remember blue has an L for left and brown has an R for right, and the earth wire is green and yellow. Okay, so make sure you're aware of those. Say the colour of the covering of the neutral wire, that is blue. Now remember, the neutral wire is 0 volts, so on a graph you get a 0 volt neutral wire, and the live wire oscillates, which means varies between a positive voltage and a negative voltage, and this change is 230 volts. So the live wire is 230 volts. The earth wire and neutral wire are 0 volts. Right, which two parts of the plug shown above protect the wiring of the circuit? So the thing that's going to protect the wire are the earth wire, and it's also going to be the fuse. Right, double insulated means something like a computer or a screen or a TV, and what happens is it's wrapped in plastic or it's double insulated. So the reason for this is because the casing does not conduct. So double insulated means that the casing doesn't conduct electricity. State which of the three wires is not required. The earth wire. So the earth wire isn't needed for a current to flow, it's just there as a safety precaution. The next question is about power. Power is equal to voltage times current, so that is equal to 20 times 3, which is 60 watts. And for this question we're trying to calculate the charge. So charge, voltage is the amount of energy transferred by the unit of charge. So it's the energy divided by charge. So it's the energy that's transferred per unit or per coulomb. Okay, so we have a energy of 300 joules, and we're trying to work out the charge. Well, if we swap these two around, then Q is equal to energy divided by voltage, and that's equal to 300 divided by 20. 300 divided by 20 is 15, and Q, which is charge, is in coulombs, capital C. Right, which one of these traces is a main supply? Well, it's this one, and this one is AC. These two are both DC, so these would be batteries. A main supply is something that we plug in, so that is A, and it is because it is alternating current. So remember, with alternating current, you get a constant change of positive to negative current. That means the current is changing direction. It's going one way when it's positive and the opposite direction when it's negative. Right, why is it dangerous to have all 5 appliances switched on and working at the same time? Well, each one is going to draw a current, and if you put all of them on at the same time, they're all going to draw a current, so therefore the current is going to be too high. So the current going through the socket is going to be too high, and therefore the socket may overheat. So current drawn is too high, and socket may overheat. Remember, if the current flowing through the wires is too great, then the wires will overheat. Right, for resistors in series, you just add them together, so the 10 plus 15 is 25 ohms. Calculate the reading on the voltmeter. Well, if we have 3 resistors that are identical, that means that the voltage across them must be the same because they're dropping the same voltage, or the energy transferred per resistor is the same. So that must be 2 volts, that must be 2 volts, and that must be 2 volts. So the reading on the voltmeter must be 2 volts. The same circuit has now been set up with 2 ammeters. Remember, in a series circuit, the ammeter reading will be the same everywhere on the circuit, no matter where I placed it. So the ammeter on A2 will be equal to the one on A1. Right, what must be fitted to the cable before it can be connected to the mains? A plug. Now remember, these are called 3-pin plugs because they are made out of brass. So just be aware they're made out of brass, and that is a safety feature as well. Brass is quite a hard material. It is a conductor, but it's also hard, so the brass pins that the plug is made out of won't bend. Okay, that's really important as well. There are 2 wires inside the cable. What are the names of the 2 wires inside the cable? Well, if they're just going to carry the current flow, then you're going to have a there are only 2. So what are the names of the 2 wires inside the cable? You're only going to have a live and a neutral. So remember, the live is at 230 volts, the neutral is at 0 volts, and this difference between the 2 makes the current flow. So when you've got a potential difference, you get the flow of current because of the difference between the 2. It is safe to connect the radio to the mains electricity supply using a 2-core cable. This is because the radio is covered in plastic. It is double insulated. Okay, so that's double insulated. The radio can also be powered by a battery. What type of current does a battery supply? Well, because a battery, remember, produces a graph that looks like this with a straight line, or a straight line like that. It is a DC only. Remember, if it wasn't DC and was AC, then you'd get a graph that looks like this. So DC produces a straight line, and AC, remember, produces a sine wave. Right, use the correct answer from the box to complete the sentence. A fuse or circuit breaker is connected to the live wire, always to the live. What happens to cause a fuse or circuit breaker to disconnect a circuit? There has to be a current surge. Okay, so an increase in current. It's just 2 advantages of using a circuit breaker to disconnect a circuit compared with a fuse. Well, if the current surges, then the circuit breaker will switch off, but all you have to do is then go and switch it back on again once you've solved the problem. So if there's a faulty light switch, you can go and find out where that is and then switch it back on again. Okay, so that we can say it can be reset. And if there is a fault, they are much easier to change as well, so therefore it is quicker to fix the problem. Okay. Right, the next question is about putting these things into a circuit, and we're going to investigate the current through a filament lamp. So this is a filament lamp, so we're going to have a battery. Normally they put the variable resistor here, so that's what we're going to do, and then they have a bulb there, and then they connect the ammeter in series into the circuit. And remember, we're going to put the voltmeter in parallel to the bulb. So this is here to vary the current, this is here to measure the current, and this is here to measure the change in voltage that goes through the bulb. And if we know the voltage and the current, we can work out the resistance. So describe how the student could use her circuit to investigate how the current through a filament lamp affects its resistance. Right, so we put the ammeter in series. So ammeter in series measures current. Voltmeter in parallel, remember it's in parallel to the bulb or lamp, so in parallel to lamp measures potential difference, which is the difference in voltage from this point here to this point here. We've got here a variable resistor, and that is there to change the current flow because we need to investigate current, so we need something that's going to change it. So variable resistor changes current flow, which is our independent variable. And then by doing this, we can then use V equals IR. So we know that V equals IR, and we're trying to find the resistance across, so R is equal to V over I. We know the voltage from our voltmeter, we know the current from our ammeter. If we use these values and plotted a table for changing the current through the variable resistor, then we could work out the resistance at different currents, and that's what you would do. Okay, so the student's results are shown in figure 1. You can see here that the current in amps is changing, and that's affected the resistance in ohms. It says describe how the resistance of the filament lamp changes as the current through it increases. So clearly, as the current is increasing, the resistance is also increasing. So as current increases, resistance increases as well. Right, use figure 1 to estimate the resistance of the filament lamp when a current of 0.1 amps passes through the lamp. So we need to continue this on, and this curve would look something like that. And then we'd have to look at what that value would be, roughly speaking. So it's looking at about 6.4. Right, the next question is asking us to use these keywords to work out what the graph is. So this one is a typical filament bulb. Okay, so here it's a filament lamp. I'm going to put FL for filament lamp. This one is a fixed resistor. So when we get V equals IR, is a relationship that is directly proportional like this when resistance is constant. So if this doesn't change, then by changing the voltage, you get a consistent relationship with current. That will only happen if the resistance is the same, and you only get that at constant temperature. So that is a resistor at constant temp. And the last one is a diode, and what it's showing you is the current will not go in the other direction. So you're only getting current flow, which is positive up that way. There is no current flow that is negative. So the current is only going in this direction, in the positive section. So that is a diode, where the current only flows in one direction. Right, so this is a thermistor, and it's asking you what is the symbol for a thermistor. That is that one. This is a variable resistor, and this is a light. Now look at the arrows, they're going towards the resistor, so it's a light dependent resistor. Okay, if they were moving away, it'd be emitting, and then you'd have something like an LED, which is a light emitting diode. Right, so suggest one way the investigation could have been changed to give a wider range of results. Well, if we look at the results, we've got it from here to here, so that's roughly 10 to 60 degrees. Well, what about going past here? Well, we could heat the water, or going this way, we could cool it down. So if we use some ice, maybe we could get the water cooler. If we boil the water, we could heat it up. So suggest one way the investigation could have been, well, heat water using kettle or Bunsen. Describe how the current through the thermistor depends on the temperature of the thermistor. So as you can see, as we increase the temperature, the current also increases. So increasing temperature increases current. Right, use figure 2 to determine the current through the thermistor at 40 degrees C. So if we draw that right up to there, and then that line across, you can clearly see it is at 0.02 amps. So that is 0.02 amps. Right, at 40 degrees C, the thermistor resistance is 250 ohms. So we've just said that V is equal to IR. We know that I is 0.02 and the resistance is 250. So if we multiply those two together, we get 5 volts. Right, what conclusion can be made from the results in figure 2 about the resistance of the thermistor as the temperature of the thermistor decreases? Right, so let's just quickly go back to this. So as the temperature goes down, you can see the current is going down. So temp decreases, current decreases. Now if you decrease the current, that means the resistance must have increased. So they are proportional to each other. Remember, resistance is inversely proportional to current, or current is inversely proportional to resistance. So if you decrease the current, you must increase the resistance. So the resistance increases. Right, the next question is asking us for the peak voltage. Well, we know from here to here is 5 volts, so we've got 5, 10, 15, 20, so the whole voltage is 20 volts. In the UK, the frequency is 50 Hertz. That means this wave changes direction 50 times every second. Okay, it says 2 lamps are connected in series or in parallel to 230 volts. Now we know if this is in series, they have to be shared. If it's in parallel, it's 230 there and 230 there and 0 volts there and 0. So that's 230 and that's 230, and for these that must be 115 and that must be 115. Okay, so if they're in series and the lamps are identical, we've just said that the voltage must be 115. Across each lamp, if they're in parallel, it's 230 volts. You have an advantage of connecting the lamps in parallel instead of series. Well, if they're in parallel, if one lamp breaks, the other lamp stays on, or current still flows through that one. Right, the light fitting does not have an earth wire connected. Explain why the light fitting is still safe to use. Well, the reason for this is it's still surrounded by this plastic insulator, and we said before this is called double insulation. So it is surrounded by plastic, so it is double insulated, so person will not get electric shock because the current will not flow through the plastic. Right, a fuse can be used to protect an electric circuit. Name a different device that can also be used. So remember, inside your fuse box, in questions before, if we just go back, there is one of these. This is called a circuit breaker, and we can use one of those. So in a circuit breaker, they are called RCCBs. Okay, so if you just remember the letters, this is a residual current circuit breaker. So that is just something that's in your fuse box. And remember, these are electromagnets that detect fluctuations in current. Right, the 6-volt battery shown in the diagram is made up of identical cells. So if each one is 1.5 and the total is 6, then we know that there must be 4 cells. So 4 times 1.5 is equal to 6. Right, the switch in the diagram is shown in the open position here. Closing the switch completes the circuit, and it says in 10 seconds 20 coulombs of charge flows through. Now remember, current I is equal to charge divided by the time taken. So that's 20 divided by 10. 20 over 10 is 2 amps. So in this question it says for 20 coulombs of charge to flow through the resistor, 100 joules of work must be done. Now remember, work is energy transferred, so that is 100 joules of energy is being transferred. So it's asking us to calculate the potential difference reading given by the voltmeter. And we know that voltage is equal to the energy transferred per unit of charge. So therefore 100 divided by 20 will give us 5 volts. In this circuit we've got a resistance of 20 ohms and a resistance of 10, so that total resistance is equal to 30 ohms, and the current must be the same everywhere in this circuit, so that's 0.5 amps. The current in the circuit is direct current, so we know it's going in one direction, and it always goes from the positive round the circuit to the negative, which is the smaller line. Remember, this is called conventional current. So the current wouldn't actually flow this way, it would always go from the negative to the positive, but in conventional current it's the opposite way round. So what is meant by direct current? It is current that travels in the same direction, so that's that one, always in the same direction. The equation which links current potential difference is given here, so we've used this a lot. This is V equals I times R. It says calculate the potential difference across the battery in the circuit in the figure above. So we know the current is 0.4 amps, and we're going to multiply that by a resistance, which is the total resistance of 30. And 0.4 times by 30 gives us a voltage of 12 volts. Now, the equation which links current potential difference and power is equal to current times potential difference. So we know power is equal to V times I. And using that, we've got a voltage of 12 volts from the previous question. And the current of 0.4, which is the same, remember, everywhere, and 0.4 times by 12 gives us 4.8 watts. Now, remember, it's asking you to give to one significant figure. This is two significant figures, so we need to round this up to 5, and then that would be 5 watts. So the answer is 5 watts because it's to one significant figure. I'm now going to put all the mark scheme answers on.